Everybody. I'm Dr. Nolan Tsuchiya, assistant professor at Cal Poly Pomona in mechanical engineering. And on behalf of myself and Dr. Paul Nissensen and Dr. Jawa, who's right here, I'll be talking about some student feedback of a recently redesigned mechanical engineering course. I'm going to use this mic because my voice is kind of dying on me, so sorry about that. So a quick background, Cal Poly Pomona is one of the 23 universities in our system. It's primarily undergraduate, and it's relatively large, 24,000 students total, and 1,200 mechanical engineers. So we're talking about a mechanical engineering course that was redesigned. So it's a fairly large amount of students that pass through this course. The course itself is called ME100L. It's sort of the first core course that all of our ME students take. It's one unit, meeting once per week for 3 hours, typically taken by freshman students. Now, prior to spring 2014, it was a very sort of general orientation course. You would learn about sort of the ME profession. You learn some library resources, and essentially there was very little technical element to it. And for that reason, several students complained that it was sort of not super inspiring as a first core course. So I think Dr. Jawa led the force on this. Basically, he ripped the whole course apart and sort of redesigned it from the ground up. And the entire motivation for this was to make it a more hands-on, sort of active environment. In addition to that, we really wanted to incorporate a technical element. So instead of learning about library resources, you're now actually getting into gear ratios and DC motors and even programming. So those are sort of the changes that were made. And because this was going to be sort of an activity, sort of hands-on course, presumably they wanted one platform to work on throughout the entire quarter. So after some discussion, they decided that this sort of robotic kit would be a good fit for this course. So for $100, you get everything here, which is essentially an Arduino. It's an open source microcontroller. I'll talk a little bit more about that later, but comes with the gearbox, the wheels, the sensors, and everything you need to program this kit. So the students worked on this throughout the entire quarter. And so essentially for the 10-week course, each week would be devoted to a sort of like a different topic. So whether it's the DC motors or the construction of the chassis, each week had its own topic. It should be noted that for any given week, there's probably some form of Arduino programming involved with this. So that's kind of a running theme throughout the course. Now, the content of the course obviously changed dramatically, but so did the structure of the course. So I want to address that here. And that's basically, it went from sort of a lecture setting where you talk about, the students would just listen, to more of an activity setting. So of that 3-hour block, the first short little bit, 15 to 30 minutes, would be just the instructor talking about what we're going to learn today. And the remainder of the time would be devoted for the students to actually build and work on their product, or build their robotic platform. And so a lot of this would be, screwing together gearboxes or programming their microcontrollers to perform some specific task for the week. So that was sort of the structural change of the course. Now, all of that has been documented in a separate paper that was presented last year. What we're trying to do here is to sort of assess the benefits and the value of that redesign. So this is fast forwarding 2.5 years later. We sort of identified this sort of narrow window of opportunity where we can actually see if those skills being acquired through the redesign were actually propagating up into the higher level courses. So at the time of the survey, which was winter 2017, we figured that there'd be a decent split of students who had taken the old version versus students who had taken the redesigned version. And again, the main idea or the motivation behind this study was to see if those skills had propagated through the curriculum and are benefiting the students today. It should be noted that this is actually a pretty narrow window of time because, after all, within a couple of years, you look at the students in their junior and senior year, all of those students will have taken the redesigned course. So it's a very narrow window. And So this, I think for that reason, this type of sort of retrospective analysis is not so typical, which is why we're excited. Obviously, we sort of decided to do this after the fact, after we saw that students were gaining some benefit. We then wanted to go back and do an assessment. So we kind of had to pick and choose. So we identified sort of the courses that we thought would be most relevant for this sort of study. So every course that you see listed here has some element of designing and programming of a real-life system. And for that reason, these are the courses that we kind of focused on for administering this survey. So onto the numbers. We collected 201 surveys, and 125 took the redesign course, and 76 took the older version. Now, these are all students in those upper division courses who are now building those projects. So it's not a perfect split, but it's fairly close. We get a decent sample from both populations. What these numbers tell us is that maybe we did the survey just slightly too late, maybe 1/4 too late. It was a simple 12-question survey. The first 8 questions were actually more just getting a feel for the student's background. 3 questions in particular, 9, 10, and 11, really allowed us to draw some interesting conclusions about this redesign. And so I'm just going to talk about those results, those 3 questions. And the question 9, which is the first of those 3, is simply how confident are you in using the Arduino? So the Arduino platform, if you're not familiar, is just this open source microcontroller, which allows you to read data from the actual environment. You can measure temperature data or distance data or whatever actual parameters you want to measure. And then you could write a script, you could write some code, and actually have the Arduino influence the outside world. So you can actuate a DC motor and so forth. And this platform is very useful for completing these upper division projects. So of the students that took the old version, this is probably one of the more interesting points, is that this is 2.5 years later. So they took the old version, they didn't do any Arduino in that version, but still 2.5 years later, they still, 50% of those students still have never used the Arduino. So it's kind of an indication that some of our students are picking up Arduino for the first time through this redesign. Another interesting point is that of the students who took the redesigned version, more than half of them feel at least somewhat confident in using the Arduino. Now, it's impossible to say whether they picked up that skill because of the redesign or if they had that skill previously, but if you look at the data for the older version, you can see that there's a definite trend. So that was a very positive note. Question 10, this was actually sort of the heart of our study. This was sort of the motivation for this entire assessment. And the question is, how beneficial was ME100 for your other ME courses? So how did the students really feel about the redesign? Did they find that it was beneficial or not? And so the numbers here are very telling, actually. And with the old version, you see that almost half of the students found no benefit by taking that course as it pertains to their senior level courses, while after the redesigned course, 28% found it very beneficial, and 2/3 of those students found it at least somewhat beneficial. So I think there's a definite trend here, which is a very positive note as well. Last question that I'm going to talk about is less about sort of the benefits and more about the structure. So the question is asking the students about their experience that they had in this course. And this pertains more to the structural change, how we went from a lecture type setting to more of a hands-on activity setting. And so those students who took the older version, maybe not so many of them preferred that style of a lecture setting. And you look at the new version, you see more than 70% of the students actually, more than 70% of those students actually enjoyed that sort of activity, hands-on environment. So in conclusion, I mean, this assessment has sort of confirmed what we already hypothesized, but we did it in sort of a controlled manner so that we can sort of gather the data. And I think we've shown that the redesign had some definite positive long-term impact on the students. Long-term, of course, being a relative sort of term. We're talking long-term within their undergraduate curriculum. So, and then, of course, we were trying to see if the skills that they picked up in the redesigned version had actually propagated up through into their upper division courses, and I think that we have determined that that is the case. Now, obviously, with some better planning, if we, for future redesigns of this nature, we would potentially want to do some kind of grade tracking or some, more sophisticated tracking. But the lessons that we learned from this study are that we can sort of validate our hypothesis about these redesigned courses. So that's all I wanted to say about that. So I'd like to leave it open to questions at this point.
Thank you. Mm-hmm.